Swayam Prabha. Digital India. Educated India.
Welcome to Structural Dynamics class. So in this class we will study how non-structural elements behave under the earthquake excitation. So in the previous class we have studied the behavior. However, in this class what we do is we will solve one example problem by taking a real near real conditions of putting non-structural elements in say 4 or 5 story building and different levels, and then give earthquake excitation at the base and check the performance of these non-structural elements, whether they are safe in the respective floors or they are unsafe. So that we will discuss in this class. So let's summarize about non-structural elements in the building. Objects inside building can slide, rock or topple when building is subjected to random shaking. So as you can see, this non-structural element, so it can be almirah, store well, table or any other furniture. Okay, so weight is acting downwards, earthquake excitation is acting putting a force at the center of mass. So the center of mass is at h by 2 from base and b by 2 from left end. So it can slide depending on some conditions, it can rock depending on some conditions, it can topple depending on some conditions. So what are these conditions? Let us look at it. So for sliding there are two necessary conditions. One is peak acceleration should be greater than frictional resistance times gravity, acceleration due to gravity, and then at the same time this acceleration should be less than gravity times aspect ratio. B by h is aspect ratio. So then sliding takes place. Now for rocking, this acceleration, peak acceleration should be less than frictional resistance time, coefficient of frictional resistance times gravity, and then acceleration should be greater than gravity times aspect ratio. And then for toppling, acceleration should be less than first gravity times aspect ratio, and it should be greater than alpha g times this bracket value. So before going to example problem, let us look at the behavior of the furniture in various floors. So let's see a small numerical simulation. So let's watch this a numerical simulation. So here you can see, so many rigid blocks are kept in a typical floor. So in first floor and also in third floor. As you can see in this one, same type of equipment is behaving differently in different floors. This is first floor and this is third floor. So now we have watched how these non-structural elements behave in different floors on the building. So we have taken an example of first floor and third floor. Now let us solve the value numerically. So assess the safety of an object given in figure. So this is the object. If it is placed in a 4-story building subjected to L centro ground motion. So coefficient of friction between object and concrete, that concrete floor, is say mu is equal to 0.45. Dimensions of object are say 2.11 meter height, say 0.45 meter width, and then length is say 0.9 meters length. So this object is placed in all floors. So now you can see this one, this we have solved. So what we did was, so we have modeled this ground building as a framed structure and gave L centro ground motion to this one and obtained acceleration response at say floor 1, floor 2, floor 3 and floor 4. So for this we have employed numerical technique. So Newmark's method of numerical techniques and found out. So at ground, peak ground acceleration is 3.417 meters per second square. And at first floor 1.728 it reduced, at second floor 3.361 meters per second square, and third floor 4.3 and fourth floor 4.7. Now when we employ sliding conditions, so it is coming to be this acceleration value, if I tell you, so these are the sliding conditions. So AEQ greater than mu times G, AEQ less than G into aspect ratio. So when we put that sliding condition at this floor, it is becoming safe, and then rocking condition it is unsafe, toppling condition it is safe. Now at first floor, sliding condition safe, rocking condition safe, toppling condition again safe, and in second floor sliding condition is safe, rocking condition not safe, toppling condition is safe. Third floor sliding is safe, rocking is not safe, toppling is not safe. So in fourth floor, not safe sliding, not safe rocking, and not safe in toppling. So that means what? So these objects are not safe in these regions. So where it is written in red, and it is safe in this one. So what is needed is, so we need to give the solution of tying these non-structural elements in that floor. So this is along one direction A. So as shown in the figure, and in the other direction we can look at the safety because the dimension has changed, so that P parameter will change. So in this one it is more safe in many cases, except in third floor in rocking condition and fourth floor sliding and rocking condition. Okay. So in summary, we have solved one example problem to show how a non-structural element which is placed in different floors will behave under the earthquake excitation. So we will have one numerical calculation in the tutorial.